some points that will touch on some of the presentations we have already heard, and maybe some points that will be addressed in other talks later on today or tomorrow. I used to make a standard mistake, which was to thank all the people who actually do the work at the very end of my slide set. But then I realized that I never get to the end of the slide set, so I never get a chance to thank them. So I've decided to thank the relevant people at the beginning, and so this is the best slide, and then everything else goes downhill from here. So I owe thanks to three individuals for what I'm about to say in this talk. The first one at the top is Mark Hauser, who changed my perspective in many ways that I'll try to make clear. Paul Petrosky, who is a philosopher/linguist, who basically did half of the work that you will see today, and then a student, Konstantinas Stephanopoulou, in my group, who is responsible for all the good ideas that you will see in this talk and the way I express them.
What's your name?
Konstantinas Stephanopoulou. All right, so this is actually the perspective that I will pursue. It's a very Darwinian perspective. So this is the perspective that I got from Mark Hauser. I was educated in a linguistics department, actually in the Chomsky tradition, where the relationship between language and thought is indeed a central question. But I used to think of that question in a way that that didn't really take Darwin too seriously. That is, I used to think of it in the following sense. Well, look, human beings seem to be the only one that have a full-fledged language capacity, and so when we ask about the relationship between language and thought, that's necessarily human-specific. Right? I was wrong in thinking about it in those terms. I think that in addition to the question of ontogeny that's very prominent in the linguistic tradition I grew up in, the phylogenetic dimension is at least equally important. And the more I read and consume the literature on what other species can do, the more I'm convinced that the relationship between language and thought that we find in our species really builds on an important edifice that's really widely shared, and I think we would be wrong to minimize the impact of this shared, inherited conceptual structure when we think about language and thought. This is not to say that other species have language, but it is to say that the contribution of language to thought is to be understood against this background of a rich conceptual structure that we find in other species. In other words, there is an interesting relationship and contribution of language to thought, but we should be mindful of not attributing too much to language, because we already see quite a bit of thought in other species, and those are not linguistic by definition. Okay? I want to say a couple of words about what I understand by language. And I realize that there are philosophers and psychologists in the audience. Usually the psychologists tend to think of language in a particular way that linguists like myself find particularly irritating. Here is the way in which psychologists use language. They use language as basically a cover term for specific languages. But linguists, at least of my kind, actually don't care about languages. We care about the fact that human beings are able to acquire specific languages. That is, we care about the fact that they have a what I like to call a language-ready brain, but we don't care so much about the final product of the languages being acquired. But when you look at the literature on language and thought, usually, even in the most careful, most detailed work, for example, I had the work of Subido in mind, you find allusions to the contribution of specific words in specific languages to thought processes. And then usually those psychologists turn to linguists to get some help and support and arguments, but they are not going to get any, at least not from linguists like me, because once you have acquired those specific languages, for us, most of the fun is already gone. What we want to understand is how come these species don't have the capacity to acquire language. It doesn't matter which one. They seem to have a brain that's quite interesting, but in at least one way, or maybe multiple ways, must be different from ours, because they are incapable of acquiring a grammatical system. Right? And the question that I would like to ask is, what is it about this language-ready brain that contributes to thought, to conceptual structure? That is, I'm going to try to resist as much as I can questions about once you have acquired a language, what's the contribution of that system to thought? Which is not to say that there is absolutely no contribution coming from specific languages to thought, but I think it's a separate question from the one I'll be addressing. Right? And so I would like to use this abstract from a very nice paper by Fagenson and Alberta, published, I think, 2008 in PNAS, where they talk about conceptual knowledge, increasing infants' memory capacity. And I just use this article, an abstract, to give you a flavor of the thing that I don't want you to think about. Which is that basically they try to see, they try to study conceptual structure in so-called pre-linguistic infants. That is, infants that were, I think, 7 months old or something like that. And to a linguist like me, that's just crazy, because there is no pre-linguistic infant. Right? At least to the extent that the creature we are talking about is a member of our species, that particular creature has a particular brain that's ready to acquire a grammatical system. It is, therefore, a linguistic creature for me. But for psychologists, it makes sense to talk about these pre-linguistic infants trying to, increase their memory capacity using conceptual structure in the absence of robust language. In the absence of robust language, this notion of robust language is one that linguists should not be interested in. Okay. Right. That's philologists who might be interested in that, but linguists should question this notion of robust language. To me, a non-robust language means, for example, a case of linguistic pathology, but not a pre-linguistic infant. All right. So this is the point that I often like to make, because when I say that I'm a linguist, usually the question I get is how many languages do I speak or do I study, and that's pointless. All right. What I'm interested in as a linguist is the fact that the creature that has a language faculty, that's us, also shows interesting cognitive traits that Mark Hauser usefully summarized under the concept of humaniqueness in 2009. And Hauser was there reviewing a whole range of studies, from about 2000 to 2009, trying to see the key cognitive differences between us and our closest relatives, or even distant relatives. And he came up with 4 points that I think are particularly useful to keep in mind when we think of us as a linguistic creature. But that linguistic creature necessarily comes with the following 4 cognitive traits. So I'm going to go through them. I'm not going to review the evidence in detail. You can go to the paper that was published in Nature by Hauser in 2009. If you're worried about Hauser and his results, I should say that none of the points that are on this slide have been questions, by experiments. In fact, I think there's massive evidence supporting Hauser's position. So the first cognitive trait that seems to be special to us is the ability to combine and recombine different types of information and knowledge in order to gain new understanding. The second point is to apply the same rule or solution to one problem to a different and new situation. Third one is to create and easily understand symbolic representations of computation and sensory input. And the fourth is to detach modes of thought from raw sensory and perceptual input. Right? So this is an attempt to summarize things that other species seem not to do. Now, there are two ways of understanding this, this phrase of species not being able, aside from us being able to do this. It may well be that we'll have to just adopt a slightly weaker position and say that most species are not very good at doing these things, as opposed to they are absolutely incapable of doing these things. I think that for what I'm about to say, even this weaker position can be adopted. I'd like to support the stronger position, but I'm not going to try to do this in this talk. What I'm interested in is that these things seem to come as a package with the particular brain that we have that's ready to acquire a grammatical system. Now, if you know the linguistic literature even a little bit, you might be tempted to try to translate some of these cognitive traits into linguistic jargon. That is, there is a sense in which, in between the lines, many people that have talked to this slide about say, well, but all these points are basically paraphrases of what grammar is, or what language is, or what syntax is. So usually people say, for example, if you take the fourth trait, to detach modes of thought from raw sensory and perceptual input, people are tempted to ask, but what's the mechanism to achieve this? And everyone's bed is usually, for example, words. Likewise, for the third one, how do you create and easily understand symbolic representations of computation and sensory input? That's just basically saying with different words that we are able to construct lexical units that are precisely those symbolic representations that we put into use in various circumstances. Likewise, the second point, to apply the same rule of solution to one problem to a different and new situation, can easily be understood as basically applying grammatical rules across a whole range of situations. And certainly the first one, the ability to combine and recombine different types of information, is related to the notorious concept of recursion in language that Hauser, Chomsky, and Fitch made famous or infamous again in their science paper in 2002. So even though Hauser was concerned with conceptual knowledge and cognitive traits in general, it's clear to many people that the reason these traits come as a package with language is that there are many linguistic properties that are buried inside those statements, and so perhaps the job of the linguist is to understand exactly what a language-ready brain contributes to these traits. And I'm going to move towards that in the rest of the talk. Okay. I've often also heard that when people see these traits, they are reminded, to the extent that they read Darwin, of a particular passage in The Descent of Man, where Darwin was basically worried about psychology in many ways, where Darwin said that man differs solely, and I've emphasized the solely, in his almost infinitely larger power of associating together the most diversified sounds and ideas. It's still a statement that linguists would like to be true. That is, because that would make their job particularly impressive in the eyes of others, because if it's really true that the only difference between us and other species is the fact that we can basically put together, use sounds and ideas and put them together. That's basically what syntacticians study, right? Or linguists in general. And so I think that there is a sense in which this position by Darwin is one that linguists would like to be true, because they would say that is exactly the contribution of language to thought. It's this ability that we can use to construct linguistic structures that enables us to go far beyond the conceptual boundaries that other species display. And I try to refine this idea in several ways in this talk. Okay. I like to talk about this particular statement in terms of a linguistic notion that I have to introduce, although some of you may have come across it. You don't need a lot of linguistic training to know that linguists have a terminology to refer to this ability to combine words and recombine them. And the most recent terminology for this process is called merge. Right? If you don't like that word, think of combine, and I'll be equally happy. Right? But the question is, what exactly does this process mean? And for many linguists, this process of merge or combination is actually surprisingly technically refined and surprisingly modular in character. That is modular in pretty much the sense of Fowler. That is, this particular aspect of combining things in language is usually demands quite a bit of domain-specific ingredients in the following sense. Linguists love to think of themselves as basically working in a domain where you need particular atoms of computations in order for you to be able to merge or combine in the ways that they study. That is, usually linguists have a conception of grammatical knowledge and of this combine operation, the merge operation, that corresponds to what I like to call the Swiss cheese model. It's a model that we owe basically to Frege, where people think of the words or the lexical units that you combine as basically having holes in them. Right? And so you can think of, for example, a verb in any language as having a hole that says, I really need an argument. And the argument basically fills that hole by combining with that verb. And linguists, when they studied this combination process, actually study pretty much how these lexical atoms are actually constructed, because without the holes in them, the combined process wouldn't actually make sense, wouldn't actually take place. So the explanatory objective of most linguists is not so much to explain this particular process of combination, but it is to explain how the atoms of computations got the holes that they do in order for the combined process to take place, right? And I find this particularly ironic because in recent years, linguists have tried to extend this merge or combination process outside of the linguistic domain. So they have suggested that this combination of process actually takes place in music. It underlies our knowledge of mathematics. Maybe it also applies in the context of theory of mind. In a bunch of domains, it's been the same process that's been cloned, as it were. It originated in the linguistic domain, but then it applies to a variety of other cognitive domains. This is an explanation that would be great, all right, but in practice it's actually very hard to make this point because the combination process, as I said, depends on specific atoms of computations that have specific requirements like nouns and verbs. And once you move outside of the linguistic domain, you lose these atoms of computations. That is, you have to find atoms of computations outside of language that look like nouns and verbs, with holes in them. And that's precisely what linguists insist you don't find outside of language. Right? And so here is an interesting case where we have a mechanism that is first of all defined in modular terms, very specific to a type of information that's being computed and processed. And then there is an attempt at an extension of crossing modular boundaries, but as you do that, you lose actually the justification for how the mechanism works to begin with in language. And what I like about this attempt to extend the basic combinatorial mechanism that we find in language to other domains is because that could actually allow me to get back to the cognitive traits that Hauser was talking about, right? That didn't refer to language per se. But in order for us to be able to grant this extension from language to other domains, we have to make this particular process of combination free from the linguistic atoms that it operates on. Right? So I will ask you to try to imagine this combination process independently of the Swiss cheese model of linguistic units. That is, I'll tell you that this combination process does not depend on the wholes that linguists think it depends on. Right? Put another way, I'll try to ask you and convince you that the atoms of computations, even in language, actually don't have the requirements that we think they do. That is, it's not the case that when we talk about things like verbs and nouns, that we have units that say, I'm a verb and I'm dying to combine with a noun so that my argument structure will be nice. Right? In fact, that's not the key essence of language, and that's certainly not the key essence of language when it comes to the contribution of language to thought. If anything, I'll tell you that the essence of language is actually the fact that this combination process that we see taking place in language after language after language is actually free of what of the particular valence that words are usually associated to. That is, we know that concepts, certainly in humans, have particular valences. That is, they have particular requirements that are called selectional requirements. So we have, for example, concepts that require one argument, two arguments, three arguments. Think, for example, of the concept of give versus the concept of sell. If you have those two concepts, you must know that sell and give must be different. You know, if you don't know this, tell me, because then we should make business together. But it's true that give is usually, requires three arguments, so I give something to someone. Sell, in addition to these three arguments, add one argument about, say, for example, the amount of money. Right. Now, so this is at the level of concepts, where the concept of give and the concept of sell must differ in some sense. What's interesting is that in languages, for example, like English, that are better studied than other languages, the word for give and the word for sell actually behave in exactly the same way, syntactically speaking. That is, it's one well-known fact in language that you don't find verbs that require more than three arguments necessarily. You can have optional arguments, but certainly you don't find verbs that require more than three obligatory arguments. So sell is actually, linguistically speaking, represented pretty much as give. It occupies exactly the same structure, it has exactly the same requirement. This, I think, is interesting because it shows that usually people think of words and concepts are basically the same thing. In fact, many philosophers use, to refer to concepts, they use English words and then they capitalize them. But actually words and concepts function differently. I think concepts clearly have heavy selectional requirements, but when they are put into words, those selectional requirements are lifted. They are lifted so that you can, for example, talk pretty easily as there was a selling event where you don't actually have to express neither who was the seller, the sellee, the amount, and so on and so forth. That's something that you can certainly express in language, but conceptually you cannot think of sell independently of the arguments and the requirements that that concept imposes. So the concepts certainly fit the Swiss cheese model that we owe to Frege. The words themselves don't have those holes. If anything, when you put concepts into words, it's as if you treated all words equally. That is, any two words can combine with one another. Of course, some combinations will make more sense than others, but in terms of the combinatorial process itself, this is the wrong model when you think of words. This is right for concepts with those holes, not for words. Words are basically these units that, instead of having holes, think of words as having glue around them. And the only thing they care about is just, combining. Right? That glue allows them to combine, but not because, they have particular holes that say, oh, now I'm done. All my holes have been filled. Rather, this gluing process doesn't seem to end in language. That's why you can combine and recombine it with. This is a particularly important difference, I think, between the language domain and the conceptual domain. And I think that this is a difference that will help us understand what the contribution of language to thought is. Because if you look at the literature on concepts in other species, obviously you find a lot of controversy whether other species have concepts in the sense that is used in the literature about us. I think we should grant a lot of concepts to other species. And clearly they have concepts that look like this. And that is with holes in them. What they don't have is an ability to abstract away from those holes and make, as it were, random combinations. That is, these random combinations will be, as it were, the source of creativity that language gives us. And perhaps, and this is a question that I'll raise and come back to in the talk, perhaps the fact that we find more creativity in us is precisely because we have found a mechanism to abstract away from the selectional restrictions that come together with concepts. And therefore, if the mechanism is language-based, perhaps then we could understand why it is that these traits that Hauser was talking about come as a package with language, because many of those traits actually had the notion of creativity behind them. Right? Okay. So another way of contrasting the Swiss cheese model and the glue model would be the following. Certainly one of the, I think, big ideas in cognitive science, the one that Luca was alluding to, is the idea of modularity. And I don't necessarily mean modularity in the sense of Fodor. I mean, for example, modularity in the sense of Liz-Pelkey's core knowledge system. Doesn't matter how many you have of these modules, but certainly that some of them exist, I think is quite clear. And the interesting feature of those modules or core knowledge systems is that they are domain specific. That is, the conceptual transaction is confined to that domain, and you can't easily, at least, just move from one domain into another. And I'd like to claim that that's basically due to the conceptual, to the selectional restriction of the concepts that inhabit those modules. In other words, I'd like to claim that, for example, in module 1, whatever your favorite module is, you have concepts of a particular shape. And they can combine only with concepts of that shape. So if you have a module about, faces or triangle, your combinations will be confined to triangles. You won't be able to combine squares and triangles. The effect of language is that these concepts are expressed lexically. And by doing so, you basically turn all these different shapes into units that look identical and combinable. if you manage to turn a triangle and a square into two circles, you can combine circles, but you couldn't combine them when they were triangles and squares. And that's basically, this arrow is basically what I'd like to claim is the contribution of a language-ready brain to thought. This is common to many species, this act of combination that's modular. This act of combination is, as it were, cross-modular. That is, language offered us a mechanism to move from a modular mind to a cross-modular mind. It's an idea that Liz Spelke has tried to express in various ways. I think Peter Carruthers at Maryland has also tried to express this in different ways. The problem with these two expressions, both Spelke and especially Carruthers, is that they believe that this is heavily dependent on words in specific languages. So all the experiments, for example, of Spelke usually try to show this effect of language, this contribution of language to thought, by tracking down the behavioral process of children as they acquire a language. That is, they say that this particular contribution of language to thought only kicks in at a particular point in the process of language acquisition. I'd like to believe that it may be manifested at different times, but this mechanism, this process, is actually available right from the beginning. That is, even in so-called pre-linguistic infants. And I'll return to this later on in this slide. Okay, all right. So, one last way of expressing what I'd like to say is that language allows us, as it were, to do conceptual transactions using a universal cognitive currency. That is, it's, as it were, the very fact that language transforms concepts or strips them away from their selection and restrictions, that we reach a stage of cross-modularity. That is, we have, as it were, language is our mind's lingua franca. If you think of the notion of language of thought, you could think of other species having their minds populated by a variety of dialects of thought. Those would correspond to modules, and those dialects would prevent easy communication across modules. The effect of language, of human language, is essentially one that says we're going to transcend these boundaries of dialects of thought by giving you a truly general language of thought. It's still going to rely on a mechanism that could be shared with other species of combinations, but that combination will be free of the selectional restrictions imposed by concepts. That would be it. That would be it, but the consequences of that it, I think, are worth mentioning. I'll give you a few. Okay, I'll skip some of these because I just expressed them in different words, and I'd like to just now allude to words that I think really expressed the sort of message that Mark Hauser conveyed to me, that when you try to characterize the contribution of language to thought, what you have to realize is the extraordinary cognitive richness of other species. Here you have perhaps I believe the best book in this domain. It actually was written by linguists, and it doesn't figure, as far as I can see, as prominently as other books, like, for example, Tyler Burge's Origins of Objectivity or Sue Carey's Origin of Concepts. Both of these books actually mention or try to characterize the contribution of language to thought, but I don't think they do as good a job as what Jim Herford has done. Jim Herford has shown that when it comes to conceptual representations that we thought were specific to humans, when you start to scratch the surface, and you approach other species and us, in fact, from a Darwinian perspective, you really quickly recognize that what we thought, we had, they also have. This is true of numbers, this is true of navigation, this is true of, well, it's true of all the core knowledge systems that Spelke, for example, has characterized. There is a literature out there of massive modularity, where, for example, you could have 200 or 250 modules. And those 200 or 250 modules indeed have not yet been found in all species. But I think that that's because of the inflation of modules in that literature. If you restrict yourself to those modules that are really well established, so the 5 or 6 core knowledge systems that Spelke always talks about agency, about number, about geometry, those you find really well in other species, right? And what Herford showed is that one of the things that's particularly saliently shared across species is one thing that at one point linguists and semanticists in particular thought was just specific to us, and that's event representations. Linguists will tell you that there is such a nice convergence, such a nice match between syntactic structure, the trees that linguists work on, in the way we conceptualize events in terms of argument structure, that usually they think that, oh, because we are the only species that have this tree building capacity of syntax, we must be the only one that must be able to represent events the way we do. What Herford has shown is that there is massive evidence that distant and non-distant relatives of ours are able to represent events in pretty much the same way we do. That is, in terms of, events happenings to certain people, to certain arguments. And not only do we know that, that this representation of events is shared across species, we also know that it has pretty much the same brain substrate. That is, we know that this event representation is ultimately rooted in the so-called declarative memory system that's associated with the hippocampus. And the hippocampus is basically providing this background for representing events, not just in us, but in other species. But if you say that, event representation that we thought was so specific to us is not so specific after all, one of the questions that linguists have begun to raise, and that I'd like to touch on, is it really the case that we represent events in really exactly the same way as other species? That is, if we have a mind that provides us with syntactic knowledge, doesn't that syntax contribute anything to event representations? And I'd like to tell you that the answer is that there is actually a little bit of contribution of syntax to event representations. And so what I'd like to use is basically some of the results that are presented in Herford's book on the origins of meaning to make a point that I think Darwin would have liked, because Darwin was always trying to make a point about a rich background that's inherited across species. That's the notion of descent. But Darwin always emphasized that in addition to descent, you have to add the width modification part that makes differences across species. So the notion of descent with modification is one that I'd like to use to tell you how, even though species other than us can represent event, there is a particular way in which syntax actually allows us to conceive of events slightly differently. And this difference is one actually that surprisingly I think philosophers have already identified, even though they are not aware of the fact that they have discovered this. And this is where I'll take you. I'll come back to these slides, but I'd like to make you think of events in pretty much the way philosophers taught us to think of them, specifically the way Davidson asks us to think of events. Davidson was one of the first to worry about sentences like, for example, sentence 1 that you have on the slide. And he thought, what's the logical form of this? Right. And Davidson was particularly interested, as most of you, I think, here know, in the fact that when I produce a sentence like 1, if sentence 1 is true, I immediately come to the conclusion that we purchased those slippers is also true. That is, we make this type of inference. And Davidson was worried about how the logical form of 1 should look in order for these inferences to be licensed, and he came up with this event representation and introducing this event argument in 1' that I take most of you to be familiar with. Okay? This event representation, in terms of an event argument, is what Jim Herford has argued is shared across species. That is, other species represent events pretty much the way we do in 1'. That is, he thought that they have a Davidsonian representation just like we do. It turns out that semanticists know that this particular event representation in 1' that you have is not quite the one that they like to use. That is, as soon as Davidson presented 1' for 1, a philosopher named Castañeda suggested that, well, if you introduce your event representation and your event argument to come up with this type of logical form, why don't you go all the way, he said, to Davidson. That is, instead of 1', why don't you have something like 1 double prime, where the event argument is radically dissociated from the other arguments. So in 1', what you have is basically a representation where a verb like purchase is associated with prototypical arguments like, subject and object, roughly. And in addition to that, Davidson added an event argument to the verb purchase. Right? What Castañeda suggested is that instead of adding 1 argument, what could be done, 1 argument, the event argument to purchase, what could be done is simply grant purchase the event argument on its own, and then let the other arguments be expressed separately from the verb. That is, the event representation that Davidson was trying to push was one where there was just 1 more argument into the verb. The event representation that Castañeda was trying to push is one where the event representation is essentially the same, it's just far more articulated. Right? It's just, the event representation is basically cut into thinner slices. You have the exact same number of arguments, it's just that you have more conjuncts, as it were. Right. This is particularly useful, semanticists have argued, to express the fact that, well, when you produce a sentence like 1, not only do you know that if 1 is true, the expression "we purchased those slippers" is true, you also are able to infer from this that some purchasing event happened. That is something that you can clearly infer from 1. But saying that some purchasing event happens, that is an expression that's stripped of, the object and subject, is actually very difficult to express if the logical form is like 1'. Okay. It's very, for example, difficult to express in true Davidsonian terms intransitive alternations of the sort "John closed the door closed," where you leave out the subject. So this transition from transitive to intransitive event expressions is actually ill-suited for a logical form like 1'. It's very well suited for an event representation like 1 double prime, because the event is simply separable from all the conjuncts. So what you do is you get rid of those units, and you are able to express to arrive at a pure expression of event. Right? That's the argument that semanticists usually make for this articulated logical form for event representation. Right? But apart from these slight differences and slight preferences to express alternations between transitive and intransitive actions, for example, what I want you to realize is that the logical form of Davidson in 1' and the logical form that's now favored in 1" is by and large expressing exactly the same event. And what I'd like to claim is that if Herford is right about 1' being present in other species, 1" is actually the event expression that's specific to humans. That is, I'd like to claim that the contribution of syntax or language to event representation and event conception is essentially the transition from 1' to 1", where we can actually articulate events in a finer grained fashion. Now, what this expression of event in finer grained fashion allows us to do is essentially one that gives us more referential abilities in the context of event. That is, if you look at a representation like 1', when you think of the notion of purchase, according to Davidson, you immediately associate it with 3 arguments: the event argument, subject, and object. And if you want to refer to this purchasing event, crucially, you necessarily have to refer to it in the context of the subject and the object. That is, they come as a package. If you have a logical form like 1', you simply have more referential potentials to refer to purchase in isolation of the agent and the theme of its argument. By cutting events more thinly, you just are able to refer to simply smaller entities that are together represented in events. And I think this is interesting because there is a debate that involves philosophers and semanticists as to whether other species, specifically our closest relatives, primates, are able to point and refer. And to the extent that they do, whether they point or refer to the same things we do. And some philosophers or semanticists claim that no, pointing is specific to us. Usually those people who make this point have not read Darwin. Those who have read Darwin know that they should be worried if it's so specific to us. But it doesn't mean that Darwin was claiming that there's absolutely no difference across species. Rather, what you see in the literature on pointing in other species is that they can refer to events on their own, but they have a very hard time pointing at specific properties of events independently of others. It's as if the event representations that they have really come as this big package where subject, object is part of the event necessarily. So other species, our closest relatives, seem to have a particularly hard time understanding, for example, transitive actions intransitively. They seem to have a particularly hard time conceiving of, for example, action verbs with particular goals when the goals are not expressed in the events. They seem to wait for all the arguments to be expressed to recognize the events. Not so for us. And I think that the reason we can basically conceive of events slightly differently from from other species is because we have a slightly more articulated vision of events that sees the event and the verb that expresses it slightly independently of the other arguments that I think of it. Incidentally, that's what I said when I claimed that once you have words, concepts basically lose their selectional restrictions. You can conceive of an event independently of the agent and the theme. Not totally independently, but certainly there is a representation that allows you to see it as separate from the agent and the theme. And I think that this is basically what syntax allows us to do. It allows us to articulate a particular representation where the event argument, the subject and object, are basically at different hierarchical levels or layers. They're simply more nesting, in our case, in our mind, than in other species. And so this amount of nesting is what could actually separate us from other species and could explain some of the range of referential options that we seem to have compared to other species. Evidence for this, I think, actually might come from the brain. I'll just mention one here. If I, no, I'm going backwards, sorry. Evidence comes from the brain, yeah. It's now quite clear that the way information is represented and transmitted in the brain is in terms of brain oscillations. That is, the brain operates on signals that are carried by different brain frequencies. And it's the interaction of these frequencies that essentially form the basis for our cognitive representations. It's how these interact. So what I've done here on this slide is show you how different frequencies, brain frequencies and brain rhythms could actually combine and synchronize with one another to essentially allow you to form the sort of cognitive representations, for example, tree diagrams that linguists like to use. Now, what I think is particularly interesting is evidence that's coming from neuroscience that indicates that humans are particularly good at synchronizing many frequencies, like, for example, the 4 frequencies that you have here. If you're interested, this would correspond to a gamma frequency, a beta frequency, an alpha frequency, and a theta frequency in the neuroscience literature. What other species seem to be good at is combining the effect of only 2 frequencies, but not the effect of many frequencies. Now, what this difference between combining 2 frequencies and combining 4 frequencies does is, as you can see, combining 4 frequencies allows you to distinguish several hierarchical layers. Right? It's not the case that it gives you hierarchy when other species don't have hierarchy. That's not the case. Even just combining 2 frequencies give you a particular hierarchy. It's just not as richly articulated. And that could be the difference, actually, between an event representation that conceives of specific arguments as part of a big event, or a more articulated event representation that is able to rely on multiple frequencies and their combined effects. And I think that this would be a difference between not the ability to provide hierarchical representations or not, but rather to provide finer grained hierarchical representations with different layers that seems to be specific to us. So the type of brain that we have is simply one that articulates conceptual representations more than other species. It's not an either or, it's more like a quantitative rather than a qualitative difference. And that could be a way, if you want, of thinking of the contribution of language to thought. It's not that without language you don't get hierarchical representations, you don't get concepts. Rather, you transform those concepts, you transform those representations in ways that allows you to transcend modular boundaries and also to articulate events in a finer grained fashion. And so, if this is the right way to think of things, Darwin was right that we should think of cognition, of language, of thought, in the context of descent with modification. That is, we should both identify the common ground, the rich conceptual structure that we inherited from our ancestors, and also the slight differences that could, in the end, make a big difference of the sort that Hauser listed. It's these traits, when characterized in the way Hauser characterized them, make it look like there is a big conceptual difference between us and other species. But if you go to the level of mechanisms that underlie those traits, perhaps you can recognize that we have simply transformed, we have simply tweaked the rich conceptual structure that we can also identify in other species. And I think I'd like to end on this note and take questions. So, thank you.
just having a little trouble understanding, say, the contrast between your view and some of the people you're saying there's an affinity, but it's not really the same thing. So Carruthers, for example, maybe Spelty too. But particularly Carruthers, and I'm thinking of him because I see how you might be inspired by Piotrowski, and he's very comfortable with the kind of thing that Carruthers is doing. When he yes. talks about transcending modular boundaries, he says, I don't have anything to say at this point, go read Carruthers or something. You know, that's more or less what he said. And so I think I can understand what the Carruthers model is, because the way he sets things up, it's as if he's doing a boxology. He's got a functional diagram of how the mind is organized. And what's happening is one of the central boxes is the language faculty, for lack of a better word. And then you have all these modules coming out, and the language faculty has both a production and a comprehension system. And what's happening is the modules are feeding into the whole faculty. A sentence gets produced, which then comes back out, and it gets fed into all the modules plus the comprehension system. So all the computation is being done really outside of the language faculty. It's just that the language faculty is architecturally organized in a maximal way to distribute information across the non-language parts of the mind. It sounds, now I couldn't create a boxology from your remarks, so that's why I was having trouble mapping it. What I got the idea was this glue allows you to transcend the modules in some sense, because you strip requirements on the concepts and they're able to be recombined. But maybe the way of asking this question is functionally, what's taking advantage of those recombinations now that those requirements are stripped?
Okay. I'll address this question by highlighting some of the differences that I see between what I take Carruthers to think about when he talks about the language faculty and what I have in mind. Whether at times I believe that my position and Piotrowski's positions are actually very, very close to one another and distinct from Carruthers in the following way. One of the ways in which Carruthers think of the contribution of language to thought and cross-modularity is that, as you pointed out, he insists on language processing being critical. That is, he has a production and comprehension system that makes it look like until you basically have reached a stage of language acquisition where you can actually produce those sentences and understand them, you won't be able to transcend the cross-modular boundary that you won't be able to transcend the modular boundaries that exist in other species and us. So for Carruthers, there is a stage, there is a pre-cross-modular stage that corresponds to a pre-linguistic stage. And crucially for him, it's the acquisition of specific words and specific languages, that is, specific pairs of sound meaning relations, that allows you to do what it takes in language to do. I would like to push back that stage and try to resist the temptation to say that until you have actually acquired the specific pairings of sounds and meanings, you'll be able to do this. If only because I think that even before you have acquired your first word, you're actually able to understand cross-modular concepts and form them, which for Carruthers I think wouldn't be possible. And the reason I think it's possible because the words we acquire, even the first ones, are actually those that are, well, some of them are actually critically cross-modular. That is, we must be equipped with a mind that transcends the modular boundaries in order for us to acquire those words that express a cross-modular concept. And I think so one of the differences between Carruthers and me is that I take this ability to be present even in the first year of life, as it were. So I have in mind the work of, for example, Lila Gleitman, that shows quite clearly that it's our syntactic knowledge that crucially contributes to our acquisition even of of our first word, certainly in the context of words expressing events, like verbs. That is, she takes our syntax, as it were, to be critical to even get to the words that we eventually require. As far as I can see, Carruthers think of the syntactic engine as basically coming after the process of word acquisition, as is the case in the light of language production. So usually children go through a one-word stage, two-word stage, and then they produce the sentences that for Carruthers are critical to cross-modular. I would like to push this back. So that's one difference. And another difference is that for Carruthers, as I think you pointed out, the critical computation takes place outside of the language faculty. I want to put the computational weight really inside the language faculty. That is, this glue model is essentially the one that says if the atoms are glued and you combine them, that's really what the language faculty amounts to. The output of the language faculty is then spread out on different modules, and those modules then benefit from these reformative concepts, as it were. Right? So they make use of them, but the computation itself takes place inside the language faculty. So I think that would be a difference between the model that Carruthers has in mind and mine, or as I think of it as all the transcript. Does that make sense?
There's more to talk about, but that's it.
Yeah, so your idea is that concepts have selectional restrictions, words don't have selectional restrictions, and that enables words to form compounds which are intermodular. So my question is, what kind of selectional restrictions would concepts have to not be recombinable and have and to form intermodular thoughts? Mm-hmm. Because the examples you mentioned were, so you have an idea of some people say selectional restrictions are very rich, mm-hmm. and some people say selectional restrictions are rather thin. And the cases you mentioned, like cell and give, mm-hmm. it seems to be on the poor or the thin side. It's cell needs requires 4 arguments. Give requires these 3 arguments. That if that's solved, the cell and the concept of cell and the concept of give need, then there is no problem of forming intermodular thoughts with that.
That's correct.
So yeah. you have to have the selectional restrictions. You have to have the concepts have to be much richer.
Much richer. Yeah.
And then I don't know how. What kind of selectional restrictions can those be to be so rich that you cannot take a concept from a certain domain and combine it with a concept from another domain?
Well, I take the modularity literature of the Spelke to actually give you reasons to believe that the units that are being processed in those core knowledge systems must be sufficiently domain specific. That is, must have properties, whatever those properties eventually are, so that they cannot be, so that they are indeed modular. Right? So I don't have a particular view on what those.
So you would explain modularity in terms of the holes.
That's correct. That's correct. That's correct. So
it's not just a question of having holes or not, but it's a question of having lots of holes.
That's exactly right. So the example that I was using of cell and give is the easiest one to show you the distinction between a conceptual representation and a linguistic representation. But of course I'm assuming that concepts, in order for them to be modular, have much richer selectional requirements. And it's those selectional requirements that essentially give you modular effects. And it's precisely because they are absent in the context of language that language allows you to form cross-modular combinations. That's the idea. So you know the ones linguistic examples that everyone knows. You know, the colorless green ideas sleep furiously. That's a pretty good example of the sort of thought that language allows you to form. Because if you took these the concepts behind those words, no one would be tempted to combine them. But it's just that once you translate those concepts into words, as it were, that this combination is fine. It may not be great semantically speaking, right? But that's going to be the job of systems outside of the language faculty to see if these combinations are appropriate, adequate to circumstances, and so on and so forth. Right? But this is why I put the computational burden on the language faculty, and then the judgment is left for the other systems of the mind.
Yeah, I'm trying to struggle to understand your position, and I know that it's a lost battle because we will take months to understand the position, and then you linguists change so quickly that when I finally understood you have another theory, so I don't know if it is worth the effort. But let me tell you this, I'm trying to locate one difficulty that I find, and I'm not sure that I am able to locate it correctly. So if I understand your position, you're basically saying there are two factors that have to be considered. One is depth. Depth in the sense of how many levels you can keep separately, which allow you to actually go and do an analysis of concepts in a way which is finer than what other animals can do. Okay? And in this sense, my story is perfectly Darwinian, because after all, what I'm saying is just a difference of a slight changing point. Okay? And the thing of, say, how many levels of co-activation you can keep separate and cross-talking is a good example of that. But that's not, let me pause and say to you that this is nice, and insofar as the hierarchical organization of this depth is concerned, Fagenson and Albert are exactly trying to do that. They're trying to show that, forget about language, but they're trying to show that indeed, even in systems that have to do with components, as it were, peripheral components of thought, like memory, you do have this depth organization that maybe animals have. But that's not the full story, right? Because it's not that if I give you more depth, you just become a human. You are saying the second, correct me if I'm wrong, the second component is the particular logical form of events that you are representing. And the fact, so basically I have, for every possible depth level that you have an infinite amount of logical forms. And what I understand that you are saying is, look, it's just because we have this very particular logical form that, for example, we can abstract out that event of being the event of buying, that we can actually combine things in a different way. And that's really what, and I think from my point of view, forget about the fact that we brute non-linguists talk about the non-linguistic mind or linguistic mind, but you can say that that is independent of acquired language. This is a property of thought. Okay. Now, this is what I don't understand. There is only one, or a class of logical forms that would allow you to do the job at a parity of level of depth. So I could imagine another completely different logical form for which you wouldn't be the thinking being that a human is, right? And you have to read a story. Besides being able to actually apply it to many cases, which I suppose you will be able to, it's a lot of work. But the point is, you have to read a story that says, okay, that particular structure of the logical form, the one that allows me to abstract out certain aspects, is really the one that does the trick. Okay? I have in mind people, like Povinelli has tried to give a story which is less detailed than this one, but similar, saying, okay, there are many things that we share with animals, including many parts of the language of thought. But we have a different language of thought than animals. That's what makes us different. And he has this idea that the difference comes from what he thinks about making relations of relations. Okay. Now, your idea is, if I understand you well, more sophisticated because it doesn't say it's only part.
But I think it is in
It is in the right ballpark, but it is a bit, because making relational relation doesn't tell you, for example, that you can abstract out events from its argument, for example, right? Good, but then you have still to say, all right, but why do we have these kind of logical forms as opposed to others that might not do the trick? And I don't know if there is any evolutionary story on that. I don't know whether there can be Darwinian, as opposed to say, well, you know, that's the mystery that you don't know how to solve. Right? Except that we sort of gather what these logical forms are when we look at language. So language is not an object of study because it allows us to think. It's an object of study because it's an external object of study which is easy to study to find out other. But you still you need to explain why do these particular logical forms are those logical forms that we can conceive at the primitive stage. And that doesn't come from the quantitative story of the letters. It doesn't come from somewhere else.
No, it doesn't come from the quantitative story, from this quantitative story. But I think that one of the things that I haven't touched on, but that linguists know, is that, you know, this act of combination, these structures that have different depth and so on and so forth, must be supplemented with series of constraints that, you know, because even if you tell me that I can combine anything with anything, that system is too unconstrained.
Yeah.
And so linguists know that even though they love to start, like I did, with the particular nature of the atoms to combine, and the particular hierarchical representations that this can give rise to, they know that in addition there's going to be constraints that, you know, essentially limit the class of possible grammars, for example, right? Now, those constraints I know must exist, but I haven't said anything about that. My bet is that some of these constraints will actually help you get to isolate the class of relevant logical forms as opposed to the others. But I think that this is a promissory note, so it's not meant to convince you. But what linguists have done is that even in this particular domain of research, they have discovered that many of the constraints that they used to think was language specific are actually constraints that you can find expressed elsewhere in other domains of cognition, so that we have recruited them in the context of language. Now, if that's true for the constraints that perhaps we will need to characterize the right class of logical forms, perhaps we don't have to give up on our Darwinian story. Because perhaps indeed those constraints that must be there could have been recruited. It's just that we still have to isolate them in the relevant domains of cognition. It's just a promissory note. So you're right to point out that these I take to be necessary ingredients of the contribution of language to thought, but they must be supplemented with a bunch of constraints that must come from somewhere. If indeed those constraints cannot be identified anywhere in cognition, then yeah, the Darwinian story has a problem. I'd just like to be Darwinian, but it's just a promissory note. You're right.
Very well on the panel. Let's thank our speaker.